Welcome, everyone. Again, really lovely that you're able to join us. It was our vision to create Bite-Sized Corrosion to be a platform where we could simply discuss all things rusty, any questions that you might have, where no corrosion topic is taboo, and where everyone feels that they can benefit, and also that no one feels that they don't know enough to even start to participate. We're really trying to open the platform to anyone and everyone. And Neil, over the last few weeks, the last few sessions, we've been looking at the survey techniques, including DCVG and SIPs. We've looked at PCM, we've looked at ACVG, we've looked at combined surveys. Now, you've done a few of those or some of those surveys, haven't you?
Vanessa, actually, the short answer is no. I've actually done all of them, every single one of them. I have physically done myself. Not necessarily with my own equipment, but every single one of those surveys, I've walked many kilometers in some fairly interesting environments and different parts of the world, both in Africa and in Europe, in order to undertake these various surveys. And there's a list of I would say, the most important surveys that we have been discussing and that are available for evaluation of pipelines by non-intrusive means. In other words, you don't have to dig it up to do the survey. What is interesting about those is that the first few surveys that we've got on the list have all been the ones where you move along the pipeline with regard to distance. But if you look at the bottom of the list there, we've got stray current surveying, for example. And there we're more interested in what is happening with the pipeline as a function of time, as opposed to as a function of distance. But it is still a non-intrusive survey technique, which helps us to characterize the condition of the pipeline.
Great. I guess we could then say you really have walked the talk, and so you do know what you're talking about.
Right.
I can't say that I've done all of them at all, but I have done a few. Neil, if we just summarize what we have been speaking about, what answers to the questions that the various techniques give us, they obviously tell us about how we can look at our coatings, whether the cathodic protection is or isn't functional, if there are defects, where they are. And then we discussed using some of the techniques just to give us a quick overview of the status of the pipeline. And I see you've got their baseline. And actually that makes me think of something. I think it's probably a good idea when we try to decide what technique to use and when to use it, if we maybe think about the concept in a couple of scenarios. So maybe when I think about pipelines, I can think of three periods in a pipe's life. We've got our pipe at the new point in it, just after it's been constructed, which is where the baseline sort of made me think. And yes, pipeline rehabilitation, but for me, that's the end of its life. And then in the middle, just knowing what's going on.
Well, you've actually got it spot on. I mean, if you look at that, to try and draw a matrix between that list of techniques and the list of desirable outcomes, you're going to have a real mishmash of arrows pointing in all directions. And I think the concept of the baseline is absolutely vital. If you don't know where you've come from, you don't know where you are. So a survey that is done without a baseline is actually a situation where you are now. It doesn't tell you whether you've improved or deteriorated with time. And that, in fact, then becomes a baseline for future work. So there's always a first survey that becomes the baseline. So looking at your very insightful classifications there, if you've got a new construction situation, most specifications for new construction of pipelines, and we're talking about coated buried pipelines, require that the coating is defect-free to all practical purposes at the time of installation. And in order to achieve that, we would normally use a DCVG survey during construction to show up any construction defects that may have happened, either through mechanical damage or perhaps a factory fault that crept through. that deals with the coating. Another requirement often is that the coating has an overall electrical characteristic. We've commonly used the figure of 100 microsiemens per square meter as the desirable end conductance for a coating system. And there we use an overall current demand test, also known as current drainage test, to establish whether the coating in its installed condition actually meets with the requirements of the specification. And then if your new construction has cathodic protection associated with it, you need to know whether the cathodic protection is working. Now, the reason why I've included the DCVG in that functional cathodic protection survey is that having done the DCVG surveys during construction, we know where those faults were. They may not all have been repaired. By doing the combined SIPS and DCVG survey, you are able to correlate then the condition of the CP system with the defects that are known to be on the pipeline.
That's very valid, is that you know what you've found before and you can tie it up and see if your CP system is actually functioning adequately to protect those. If it's not, obviously that calls in for some further design or modification or repair by the contractor.
Or intervention to repair those defects if it was not done after the construction defect surveys.
Just a point, Neil, if I'm the surveyor and I tell you that I don't have the equipment, can I just use the equipment that I have at hand?
Absolutely not. You need to use the equipment that is best suited for the purpose of the survey, as opposed to using the equipment that you happen to own.
So choosing the survey technique based on your equipment is not the right way to do it.
Certainly not. So once we then have the pipeline constructed and approved and or taken over and accepted, then through the pipeline's operating life, one undertakes routine maintenance and routine monitoring. And typically, for example, just as in fuel and gas pipelines, hazardous pipelines, they do an internal corrosion inspection using intelligent pigs every 5 years or so. So too, you should also do a similar survey of the condition of the coating, because coatings degrade, they may get damaged, there may have been physical intervention. I think the worldwide figure for pipeline failures as a result of third-party intervention is something like 30%. You know, somebody can come along and lay a cable and cover the cable, and the pipeline operator never knows about it. Meanwhile, they may have struck that pipeline and damaged the coating, may have caused a short or a current drain or something like that. And in fact, we even have situations where illegal connections are made onto pipelines. And these surveys help to identify those situations. And in the straight current scenario, which is particularly relevant in South Africa, but it's not unique to South Africa, because there are many other countries that have DC rail systems as well. The straight current system will change if, for example, a new traction substation is installed. And so it is necessary to check that the protection of the system is maintained through the life of the pipeline on a regular basis.
And just related to that, I've noticed, and sadly the destruction of our rail network, sometimes the reverse happens. So we have designed a system for straight current mitigation, and then the rail is stripped out, and then maybe you've got too much potential on your pipe. So again, those potential recordings can be very valuable. And then in terms of rehabilitation?
There are a number of things that you might want to do if you get to a situation where you want to do some troubleshooting or investigation. Unfortunately, there are many situations where people don't know where their pipelines are. And we've just recently had a situation where an intelligent pigging contractor approached us to say, well, can you tell us exactly where these pipelines are? We know that they run under this road somewhere. And one of the best ways of actually pinpointing pipeline routes is, in fact, the PCM survey. It is probably the most precise long-distance pipe locator that we have available. If you want a quick overview of the condition of a pipeline, where you want to evaluate where the problem areas are that may require further investigation, again, the PCM survey, the current mapper, is an ideal instrument for that operation. If you've got a situation where you're putting a lot of current into a pipeline and you haven't got protection, and you're saying, well, where's my current going? I'm putting in 10 or 15 amps when I should only need 2 amps. Where's it going? What's it doing? Because I'm not seeing the effect on the pipeline. There again, the PCM is the ideal tool to evaluate that situation. Often we find that cathodic protection systems get neglected over the years, and you may find that the operator then says, oops, is my CP actually effective? I don't know. In that situation, the close interval potential survey is probably the ideal tool. If you have a pipeline where the cathodic protection was installed many years ago, and 20 or 25 years later, the system is not quite working so well, perhaps because of coating degradation, you need to know where you need to supplement the CP, or in fact do wrapping repairs. And again, the SIPS is probably the best choice for that situation. Once you actually come to do the rehabilitation and you want to find out what you're going to do where, a combination of the SIPS and the DCBG provides a good indication of the areas that will require physical intervention in terms of upgrading coating systems, for example. And I know certainly overseas, there are a number of situations where you actually have a rehabilitation train. So they go along and you excavate the pipe, strip it, wrap it, and backfill it. And you just move down the pipeline undertaking that sequence of events.
You'd only want to do that if you knew that there was a problem in the area, hence the surveying.
Correct. And if you need to really pinpoint your excavation areas because you have limited resources, for example, then the precise location of coating defects is best undertaken by either DCBG or ACBG, bearing in mind that the ACBG, as we know, is somewhat more sensitive than the DCBG, and that has to be kept in consideration when you undertake these surveys. And so we've got this matrix, and this is my personal, professional, technical choice, I suppose, is the word. It's not cast in stone. It's what I would do if you were to ask me the question.
Right. I think that's a very valid thing. It's a good starting point, and certainly very helpful to have that as an idea of where to go and which technique to do when. But as you say, circumstances may well determine that what we would normally choose isn't what is chosen because of circumstances or access or some other reason that I can't necessarily think of right now. Thanks, Neil. I think that's helpful, and I hope that everyone on the call has also found it helpful to have an idea of which survey technique should I use.
I think there's something that I want to really emphasize, and that is this. We've looked at a lot of different survey techniques. As a pipeline operator or owner, you need to make sure that you use all the tools that are available. Don't get taken in by somebody who wants to sell a particular technique or device. It happens to be the one that they have available. There are a lot of people available who have got experience in these techniques, and you need to get hold of those people and say, well, look, this is my situation. What should I be doing? And get professional advice. And always bear in mind that no single survey is perfect. It's not going to necessarily give you all the answers. And you may have to use a number of different techniques in order to get a really good condition evaluation of a pipeline situation. And that actually brings me a technique that is something that is used for pipelines that cannot be pigged. And I think we alluded to it earlier in the series. It's called ECDA, External Corrosion Direct Assessment, a formalized technique where they use multiple sources of data in order to do a risk analysis on a pipeline and undertake interventions to prevent that pipeline from corroding and possibly leaking, rupturing, causing environmental damage, or even fatal consequences.
I think that's possibly something we can talk about in a future series. I think ECDA is becoming not only used in the oil and gas industry, which is, I think, where it started, but also increasingly within the water and other pipeline industry. So we can certainly look at that. So I see that there is a first question here from someone who's typed it in. And the comment is that we have never undertaken an overland survey on our pipelines at all. Where should we start?
Well, as you said yesterday, I think let's start at the very beginning. I would respond to that question with a question is, what do you want to know? Do you want to know whether the pipeline is likely to corrode? Do you want to know whether the wrapping is in good condition? And quite honestly, my preferred get-go survey is probably always the combination SIPS and DCBG. And then, of course, you're going to come back to me and say, but I haven't got cathodic protection on my pipeline. You don't have to have cathodic protection on the pipeline in order to do an overland survey. So there are two things. The DCBG is always done with an external impressed current. And so you can do a DCBG survey, which will tell you about coating condition. And you can do an overland survey with no cathodic protection, which will give you a risk profile based on the natural potential of the pipeline, and also probably tell you whether you've got any stray currents that you need to deal with.
Yes, my limited experience has been that the combined SIPS DCBG is a good survey to do. Certainly can be time consuming and challenging because it's not a quick survey. So I think that's the other thing. And obviously that's all the information we were given, but is also how quickly do you need answers? Because if you're looking for an answer this afternoon before your meeting, this was the wrong time to ask the question. But if you've got time, I think the SIPS DCBG is probably a good place to start. It can be quite challenging in urban areas, built up areas, because of access over the pipe servitude, but certainly one that we can get usable information from. And then, yes, determine if the CP is there, is it functional or fully functional? And if there isn't CP, do we need it because our pipelines are actively corroding? And where do we need it mostly?
In terms of your question, do we need it? I mean, that's also based on environmental parameters. So if you don't even know what the ground conditions are like, you don't know whether you need cathodic protection or not, or whether your pipeline is corroding or not. So actually you need all that underlying first principle data as well. And if you want a quick answer as to what you might be faced with in terms of a pipeline situation, then the PCM survey is probably the point of departure, because it will tell you very quickly, and that's a relative term, it will tell you quickly compared to, say, doing a DCBG or a SIPS survey, where you can survey 10 or 20 or 30 kilometers in a day by going to various accessible points on the pipeline, as opposed to the close interval surveys where you are going to average between 2 and 4 kilometers a day. And when you've got 300 kilometers to survey, you've either got to have a long piece of string, or you've got to appreciate that it's going to take some time to get those results.
I do also think that some of the municipalities are really trying to resuscitate some of their infrastructure. And of course, the water infrastructure would be what interests us largely. And not knowing where their problems are, where to start, it can seem very overwhelming. And I think the other key thing is that we should never discount the value, the tremendous value from the leak history. So if you've got that, it certainly gives you a pointer as to where your problems are probably originating, and can often give valuable clues when we try to solve or resolve the challenges.
Yeah, well, if you're not dealing with water, but you're dealing with oil and gas and fuel and so on, you don't want a leak history.
Well, that's true too.
And that's why you do the surveys in a preventative capacity rather than in investigative capacity.
I think it would be true to say that generally the oil and gas industry, because they are more regulated, maintain their cathodic protection systems to a greater extent. I think it's the water industry where a lot of these systems have been left either vandalized or just non-maintained. Electricity accounts haven't been paid, so rectifiers aren't operational. And I think that's where this sort of approach can be helpful.
One of the interesting challenges in that regard is that in a typical municipal environment, you have an electrical department and you have a plumbing department, and cathodic protection crosses boundaries. So the electrical people say, oh, that's a pipeline situation, we're not interested. And the plumbers say, oh, no, that's an electrical installation, we're not interested. So the CP falls through the cracks, and the net result is that your infrastructure deteriorates, and then 10 or 15, 20 years down the line, your 50-year design life system is so badly deteriorated, it has to be replaced. And this whole situation is not quick fix and short-term results. It's the long haul.
And it's also not a cheap exercise. I think there's also a perspective that the cathodic protection is expensive, so we won't do it. But actually the surveying, replacement, repair work is even more expensive. So please keep, just as you go to the dentist every 6 months or a year to check your teeth, because actually dealing with cavities and extractions and root canal is awful. Similarly, in the pipeline industry, if you keep your CP system operational and keep an eye on it, you don't have to deal with the very expensive excavations. And as you say, in oil and gas, the whole environmental nightmare that is associated with the loss of goodwill and all of those intangible costs as well. Well, thanks, Neil. I think we're pretty much out of time. Remember that all of our bite-sized corrosion conversations are available virtually. You can either sign up on our digital platform, which is the Teachable platform. They're also all available by clicking through on our website.
That's the picture that we actually don't want to see. That is a real situation on a real pipeline that was found by the use of non-intrusive survey techniques.
And let's hope that we don't find it on your pipeline. Thank you again, everyone, for joining us, and we look forward to seeing you again in the new year. Have a wonderful rest of the day. Thank you.